Chemicals. What are they? What do they do? How can I use them to launch a potato-like projectile over 50 meters at high speeds? And how does any of this have anything to do with AP Physics 1? Well, fear no longer, because soon some of your questions will be answered in Chemical Potential Energy is Just Work in AP Physics 1.
Now you might be wondering, what is work? Well, work is simply a force applied over a distance. You can find work by finding the cross product between a force and a distance. And since chemical potential energy is magic to us AP Physics 1 students, we just say that this is equal to chemical potential energy.
Alright, so we have the potato cannon set up. The barrel's 91 centimeters long. It is 117 centimeters above the ground. And it's set up at 30 degrees above the horizontal. And we're going to be firing it into the woods. Hopefully we don't hit a deer.
Alright, so the potato weighs about 200 grams.
Safety first. This is our propellant. Mink hairspray. Let's do this. Yeah, that's going to be about 53 meters. Now that we fired the potato cannon, let's try to find the average force acting on the potato while it was fired. But first, let's establish a few things. The first is that air resistance doesn't exist. The second thing is, we are only looking for the force acting on the potato. Any energy lost in the system, we'll just ignore it. Who cares? Now let's establish what we know. We know that it took the potato 2.3 seconds to travel. We also know that it started at a height of 1.17 meters and ended at a height of 0. We also know the horizontal displacement was 53 meters. Things we do not know are the initial velocity going at 30 degrees above the horizontal, the velocity in the horizontal, the initial velocity in the vertical, and the final velocity in the vertical. First, let's solve for the initial vertical velocity. We can find this by using this kinematics equation. We begin by plugging in what we know. The acceleration is negative 10 meters per second because this is acceleration due to gravity near Earth's surfaces. It is negative because we defined up as positive. Next, we solve for the initial velocity. The initial velocity in the vertical is 11 meters per second. Now to find the horizontal velocity. Since the velocity in the horizontal is constant, it'll be much easier to find. And we find that it's 23.04 meters per second. By adding the two vectors together, we find that the initial velocity of the potato 25.5 meters per second. Now that we know the initial velocity of the potato, we can find the chemical potential energy of the system. Since we don't really care about the energy lost in a system, we can assume that the system is closed, which means E1 equals E2. E1 is potential energy, and E2 is kinetic energy. We can solve for kinetic energy, so that means potential energy is 65.025 joules. Since we don't understand chemicals in Physics 1, we can assume that this is equal to the work done on the potato, which means that there are 65.025 Newton meters of work done on the potato.
Now that we know the work done on the potato, we can find the average force acting on the potato. We already know that work is a force applied over a distance. We also know that there is 65.025 Newton meters of work done on the potato. We also know what the distance is. The distance is the length of the barrel, which is 91 centimeters. Now we can solve for force.
And we find that, on average, 71.5 newtons of force are acting on the potato.
That's all, folks.